In this video, I'm going to teach you all about algebra and how to solve the most basic problems. In later videos, we'll do more complicated ones, but we're going to start small in this video. Okay, first let's talk about the additive property of equality. Now, these are all fancy math words, but basically what it means is that plus and minus are opposite things. So, for example, if I add 5 to something and then subtract 5 from something, those things cancel out. It's like they totally go away. So what does that mean for us in terms of algebra? Let's do an example. Okay, here we have the problem x plus 5 equals 12. Now this is a classic algebra problem. Algebra is when there's a missing piece of information in an equation. We usually use a letter to represent that, like x or a or y. And we need to figure out what that missing piece of information is. So the first thing I want you to always do, no matter how easy the problem is make a dotted line down the equal sign. Now, whatever you do on the left of the dotted line, you have to also do on the right of the dotted line so that they'll stay equal. I'll give you a quick example. If two people both have the same amount of money in their pocket, and you add some money to one guy's pocket, you have to also add some money to the other guy's pocket so that they will stay equal. They'll still have the same amount of money. So here's the deal. We want to figure out what x is in this equation. So down at the bottom, in the end, we want to know x equals what. So the reality is we've got a problem here with this number 5. We need to remove it so that we can have x all alone. So this is where the additive property of equality comes in. The fact that plus and minus are opposite things. So if we want to remove a plus 5, we should minus 5. That way those will go away in the end. But if we're going to subtract 5 from one side, we have to also subtract 5 from the other side so that they stay equal. So if you do that, plus 5 and minus 5 cancel out. You're left with just this x all alone. And here on this side, 12 minus 5 is 7. So the solution to this algebra problem is x equals 7. Okay, let's do another example. Look at this one. It says 8 equals y minus 3. Now don't be confused just because it's a y instead of an x or because it's on the right side instead of the left side. Really doesn't matter. The point is we have an equation and we have a letter, and that represents a missing piece of information we want to find out. So like everything, we just make a dotted line down the equal sign, and we know in the end we want y all alone on the right. So in order to do that, we're going to have to remove this minus 3. The minus 3 is a problem. So what's the opposite of minus is plus. But if we do plus 3 on the right-hand side of the equal sign, we also have to add 3 on the left-hand side of the equal sign so that they stay equal. Now the reason we did that is because minus 3 and plus 3 cancel out. They get removed. And on this side, so all we're left with is our y all alone. And then on this side, 8 plus 3 is 11. So we found out that in this algebra equation, y must be 11. Okay, now let's talk about the multiplicative property of equality. And basically, in so many words, it's the idea that times and divide are opposite procedures. So if you multiply something by 2 and then divide it by 2, you end up back where you started. Okay, let's do an example to show you what I mean. Okay, here's a quick, easy problem. It says 3 times x equals 24. So it's an algebra problem because there's an equal sign and there's a letter that we need to figure out what it is. Now, I know some of you can just look at it and know, but we're practicing these steps so when we get more complicated problems, they'll become very easy step by step. So first thing, we draw a dotted line down the equal sign. Whatever we do on the left, we must also do on the right. In the end, we know we want to have x all alone. So we have to remove that 3. Now it's 3 times x, so the opposite of times here, we can remember, is divide. So if we want to remove 3 times x, we have to divide by 3. But if you do it on the left, you must also do it on the right. Okay, 3 divided by 3 is just the number 1, so there's no need to write it anymore. We have x all alone. And 24 divided by 3 is 8. So we just solved that algebra problem. Let's do one more. Okay, our second example, we have negative 2 equals w divided by 4. Again, make a dotted line down the equal sign. What is the variable we're trying to find out? We're trying to find what is w. So in the end, we want w all alone. Our problem is this 4. We need to remove it. Well, on the right-hand side here, if you have dividing by 4, the opposite of dividing by 4 is multiplying by 4. But if you multiply by 4 on the right side, you have to also multiply by 4 on the left side so that they stay equal. 4 divided by 4 is just 1, so there's no need to write it anymore. We're left with w all alone. And now 4 times minus 2 is minus 8. So those are examples of using the multiplicative property of equality to solve algebra problems. Okay, well, of course it's going to get more complicated than that. Let's now do a couple of problems that require 2 steps. So it's important to remember again that plus and minus are opposite, and times and divide are opposite. So that's going to help us with isolating our variable. Let's do a first example. Okay, here we go. Example 1, 3x plus 7 equals 22. Now, like all the other examples, we put a dotted line down the equal sign, which tells us whatever we do on the left, we're also going to do on the right. Now, again, x is our variable. That's our missing piece of information. So in the end, we want to know what does x equal. Now, the problem here is we have 2 different numbers that we need to remove if we're going to isolate x. So the question is, which one do we do first? In general, the rule of thumb, the number that's farther away from the x is going to be the easier one to remove. So this plus 7 here is farther away from the x. We do the opposite of plus is minus. Since we did it on the left, we have to also do it on the right. Okay, next step. Plus 7 and minus 7 cancel out, and we're just left with this 3x from here. And what does that equal? But 22 minus 7, which is 15. Now we're not finished because we really want x all alone. So this, we notice here, 3 times x, we have to remove the 3. The opposite of times is divide. So we divide on both sides so they stay equal. And 3 divided by 3 is just 1. So it cancels out, no need to write the 1, and 15 divided by 3 is 5. So we've just solved a 2-step equation. Okay, here's a second example. Now don't be bothered if the letter's on the right side or the left side, or if it's an X or a Y, it doesn't matter. We still start off by making a dotted line. And in the end, we're missing the letter U. So I'll write down here, in the end, I want U all alone isolated, and I want to know what it equals. So again, we've got a problem because we've got to remove the 4 and the 17. First thing I'll remove is the one that's farther away from the U, the 17. Minus 17, the opposite is plus 17. But since I did it on the right, I have to also do it on the left. And so for the next step, these cancel. And all I have here on the right-hand side is U over 4. All I have on the left-hand side is 11 plus 17, 28. Next step, I need to remove this 4. It's dividing by 4. So the opposite of dividing by 4 is multiplying by 4. We do that on both sides. And then here, 4 divided by 4 is just 1, so there's no need to write it. We're left with just the U all alone. And 4 times 28 is 112. So that's the solution of example 2. Okay, now what if it gets a little more complicated? Let's do another example, this time with parentheses. Okay, looking at this example, our first step, like always, draw a dotted line down the equal sign. Now, before we can do much, we should distribute this parentheses. So if you remember distribution, we can call it the rainbow method. It's going to be 9 times U minus 9 times 2 is minus 18 equals to 27. Now it's just a regular 2-step equation like normal. First thing we're going to do is we're going to say, okay, in the end, I want to know what does U equal, but I have to remove this and this. First, we'll remove the minus 18. We get plus 18. And we have, this cancels out. And we have 9U left over equal to 45. Now to remove the 9, we just divide by 9, and we get that U, those cancel, U must have equaled 5. Okay, now what if we have fractions? All this popped up, it's real ugly looking, but don't be scared, we still do it the same way. Draw a dotted line. We want V all alone in the end. So we have to remove the plus 1/2. How do you remove a plus 1/2? You just minus 1/2. Minus 1/2. Now you can do this by hand or you can do this by calculator, but in the end you would get that v equals minus 11/10. Okay, similarly, we've got an ugly fraction here. We still have to make a dotted line. We want our x all alone. I'm going to do this in 2 steps and say, okay, first I'm going to remove the 4. I'll multiply both sides by 4. That will cancel, and I'll end up with 5x equals to 140. And then to remove the 5, I'll just divide by 5, and I get a final answer of x equal to 28. So even though it's fractions, we still do it the same way. Okay, we'll just do 2 more examples, getting a little bit uglier, but again, we do it the same way. We want, in the end, x to be all alone. So I look here, I'm going to have to remove that and that. The one that's farthest away from the x is the one I remove first. So dividing by 9, the opposite is multiplying by 9. So I'll do that on both sides, and I will get that x plus 29, because remember 9 divided by 9 is just 1, so it gets removed. And on this side, 9 times 3 is 27. Okay, now we just want to remove this plus 29, so we minus 29 from both sides. And that will cancel. Plus 29 minus 29 goes away. 27 minus 29 is minus 2. Okay, here's one more example. Again, dotted line down the equal sign. I look and I see an x. So in the end, I want x equals. But actually, we have a lot of things we have to remove here. We have to remove this number, this number, this number, in order to get x all alone. So first thing we move is the one that's the farthest away from the x. It's this dividing by minus 3. We'll multiply both sides by minus 3. That will cancel. We're left with 5x minus 12 equals to positive 18. This should look familiar like the earlier examples we did. Now we want to remove the next farthest thing, so that's going to be the minus 12. We add 12 to both sides, and we get minus 12 plus 12, 5x equal to 30. Now we want x all alone, so we divide by 5, and we are left with the fact that x must equal 6.